Why gummy bears grow in water but not in salt water. A presentation by Tim Lyons. I'm about to give a very quick presentation on gummy bears, and here's why you should care. First, you're going to observe osmosis in action and understand how it works. Secondly, you'll gain a better understanding of solubility and solutions, and some very important lessons for healthcare providers. And three, you'll have a huge bag of gummy bears left over because gummy bears come in huge bags, and this experiment only required 2. Here are the supplies that you'll need: 2 cups of water, 2 gummy bears, and some table salt. And here are the steps. It's very easy. First, you're going to take gummy bear number 1 and put it into a cup of plain water. Secondly, you're going to take a cup of water and you're going to add salt to it. Stir the salt into the water and keep adding salt until the water will not absorb any more salt. You'll know this when the salt starts to pile up on the bottom of the cup. That means that the water is saturated with salt. Then you're going to put gummy bear number 2 into the cup of salt water and allow the gummy bears to soak for 8 hours. So here's what my experiment looked like. You can see the green gummy bear on the left is what I refer to as gummy number 1. It is in plain water. And gummy number 2 is red, and it is in salt water. So this is the before image. This is what the gummies looked like at 10:15 p.m. My hypothesis: gummy bear number 1 in the plain water is going to swell up, whereas gummy bear number 2 in the salt water will not. And here are the results. At 6:30 a.m., which was 8 hours and 15 minutes later, you can see that gummy bear number 1 in the plain water has swollen up. Gummy bear number 2 has pretty much stayed the same, but just swollen ever so slightly. And you can see gummy bear number 3 is just my control gummy bear, which was not in any water. So as predicted, and you can see in this close-up photo where I put them all 3 next to one another, gummy bear did swell up the most in the plain water, and gummy bear number 2 only swelled up just the slightest bit. So why? Why did this happen? In order to understand, we're going to need to know 3 things. What is osmosis? What is a gummy bear made of? And what is saturation? So osmosis is a process by which molecules of a solvent pass through a semi-permeable membrane from a less concentrated solution into a more concentrated one. So from low concentration to high concentration, thus equalizing the concentrations on each side of the membrane. So it's about the pursuit of equilibrium. Now, water is the universal solvent. It dissolves more substances than any other liquid. It does this because of the unique polar arrangement of H2O. In an H2O molecule, which contains 2 atoms of hydrogen and 1 atom of oxygen, the hydrogen atoms attain a negative charge, and the oxygen atom attains a negative charge. Therefore, one side of the molecule has a positive charge and one side of it has a negative charge. This creates an attraction to water that is so strong that it pulls other molecules apart, dissolving them. Now, this dissolving can either involve simply separating the atoms of a different substance. So take, for example, or separating the molecules of a different substance. So take glucose, for example. Water is simply going to break up glucose into its individual molecules. But in the case of something like salt, NaCl, water has such a strong attraction that it actually pulls that compound apart, and you end up with sodium positive ions and chloride negative ions. So let's go back to osmosis and talk about types of water solutions. Now, when you talk about osmotic solutions, it's always relative to a second solution. So I can't simply point at a cup of salt water and say that that is a hypertonic solution. I can only talk about that when I compare it to another solution. Or a substance. So a hypotonic solution, a hypotonic water solution, is one that has a lower percentage of solute and a higher percentage of solvent, so in this case water, and than the second solution. So that a hypotonic solution wants to give away water. A hypertonic solution has a higher percentage of solute and a lower percentage of solvent. Therefore, it wants to take away water. An isotonic solution has the same percentage of solute and the same percentage of solvent, and so it's just okay with the status quo. So water might move back and forth between it and another solution, but there will be no gain or loss. So let's talk about gummy bears. The main ingredients in gummy bears are sucrose, starch, and gelatin. And you can see the chemical equations here. All of these are highly soluble in water. They have no trouble dissolving in water. And as a result of that, they are creating solutions and will have, when they're placed in water, they're going to act like they have a semi-permeable membrane that can absorb water. Actually, the gummy bears will act as if they have a semi-permeable membrane that can absorb water. And they're going to be subject to osmotic pressure. So, talking in terms of osmosis, in relation to gummy number 1, the plain water is a hypotonic solution. Molecules from the plain water are pushed or pulled into the gummy and it swells up. This is why IV solutions must contain salt and other solutes. Pure water is a hypotonic solution for red blood cells, and it will cause them to swell and explode, which is called lysing. In relation to gummy number 2, the salt water is an isotonic solution. The salt water has a concentration of solvent to solution that is roughly equal to that of a gummy bear. So it's not attracted to the gummy bear the way that the green one was. So in closing, when we ask ourselves, why did the green gummy bear swell up and the red gummy bear didn't? It's all about osmosis. It's all about osmosis and the power of water as a universal solvent. This is a great trick to show to your kids in order to teach them how osmosis works. Just don't let them eat too many gummy bears afterwards, because some people have bad digestive reactions to gummy bears. Thank you for listening to my presentation today, and I hope you have enjoyed it.